Welcome back, students. We are going to be classifying equations today, and I think this is about as long as I can keep up this accent for. We are going to be defining equations into three different types. We are either going to have conditional, dependent, or inconsistent equations, where a conditional equation is an equation that is true for specific values of a variable. This has been everything we've done so far. Every equation we've done, we've gotten an answer, and so that is a conditional equation where our answer is the condition. Okay, if x equals the thing we got, then the equation's true. A dependent equation, on the other hand, also known as an identity, this is an equation that's true no matter what. So think about x equals x. That's just true. No matter what you put in for x, that is always going to be true. Okay, whereas an inconsistent or contradictory equation is going to be never true. So for example, if we say that 0 is equal to 3, one, there's no x there, so I can't even plug anything in. But even if there was, there's nothing I can do that's going to make that true. 0 just does not equal 3. Okay, so we have three different types. We're going to see each one real quick. So number 17, part A here. 4x plus 1 equals 4x. If I try to solve for x, we're going to see what happens here. I would subtract x from both sides, or subtract 4x from both sides, I should say. So minus 4x, minus 4x. When I go ahead and do that, on the left side, they cancel. And on the right side, they cancel. So I'm left with 1 is equal to 0. Well, that's just not true. Okay, so when you get to something that is not true, that is called a contradiction. Okay, so contradiction, otherwise known as an inconsistent equation. Okay, same thing. All right, part B, 5x plus 2 equals 5x plus 2. Notice these are the same. So if I subtract 5x plus 2 from both sides, I'm going to get 0 equals 0, which is still the same. Okay, so let's go ahead and show those steps real quick. If I go ahead and subtract 5x and subtract 2 from both sides, therefore trying to cancel out everything here, I'm going to get that 0 on the left is equal to 0 on the right. Now I know you're thinking, well, why do we subtract everything? What if we only subtracted the x's? Then what would it look like? Okay, let's delete the minus 2 from both sides. We would still have that the 5x's cancel, and we'd be left with 2 equals 2. And hey, that's also always true, isn't it? That's just a fact. Okay, so we call this being an identity, or being dependent. Okay, where this has infinitely many solutions. No matter what you make x, this is just always going to work. Okay, all right, part C. Here we're just going to have a plain old conditional statement where if I go ahead and try to solve, I'm going to get an answer. So if I subtract 1 from both sides, the ones on the left cancel. I end up with 3x is equal to 6. Go ahead and multiply both sides by 1/3 because it's the reciprocal of 3. And I am left with x is equal to 2. All right, so because I get an answer, one value for x, this is called being a conditional equation. See way up there at the top. So all we have to do is say conditional, where this is only true if x equals 2. If x equals anything else, then we don't have a solution. All right, so now we can do the fun part, some applications. So let's focus in. At a school concert, the total value of tickets sold was $3,360. Student tickets sold for $6 and adult tickets sold for $12. The number of adult tickets was 6 less than 5 times the number of student tickets. Find the number of student tickets sold. Okay, so what I always like to do is first identify the question, which in this case is to find the number of student tickets sold. So since that's the thing I'm looking for, I assume that I don't have that answer in the problem anywhere. And so I'm going to make that my variable, where I'm going to say that x is going to represent the number of student tickets sold. Okay, so now I'm going to try to write an equation with x in it that will allow me to solve. So based on the rest of the information I have, the main thing I notice is that I have the total value is $3,360. Whenever it says total value, you should always think about when you go to like a grocery store and you buy multiple items, the total is what you get when you add together the costs of all those items. So for instance, if you bought 3 bunches of bananas and 2 frozen pizzas, you would multiply 3 times the price of a bunch of bananas and 2 times the cost of a frozen pizza, add that together, and you would get your total at the cash register. So normally, whenever you're finding a total, you're just going to add up the sum of each of the things. So if we add together the total cost or the total money brought in by student tickets and adult tickets, it should equal 3,360. Okay, so what we can say is that amount 1 plus amount 2 is going to be equal to the total, well, and I can even say total amount here, where now we just have to define what are each of these amounts. So the way you find out what amount 1 is, let's say amount 1 represents the amount brought in by the student ticket sales. We would take $6, which is the cost of 1 student ticket, and multiply it by however many student tickets we sold. So we would do 6 multiplied by, in this case, x, because x is the amount of student tickets we sold. Then we would add to it the cost of an adult ticket, which is 12, and we would multiply by the number of adult tickets sold. So for right now, I'm going to just put a set of parentheses for a second, but we'll come back to that. And on the other side, this is going to be equal to the total amount, which was $3,360. Okay, so now that set of parentheses, we need to multiply 12 by the number of adult tickets sold. And the number of adult tickets sold was 6 less than 5 times the number of student tickets. 6 less than 5 times the number of student tickets. Well, 5 times the number of student tickets, that's 5 multiplied by x. And how do we do 6 less than that? Well, subtract 6. So 6x plus 12 times 5x minus 6 will give us the total, which is $3,360. So the key there is to define a variable, x is the number of student tickets, and then define the number of adult tickets based off of x. So now we have this nice equation where we can just go ahead and start solving. If I go ahead and extend a red line through my equal sign, just like normally, we are going to distribute this 12 to the 5x minus 6. So we have 6x in front, and that distribution is going to give us 60x minus 72, where 3,360 is still on the other side. If I combine like terms here, I have 66x minus 72. Right side stays the same. I can then go ahead and add the 72 to both sides. That will leave 66x all alone on the left side of this equation. So 66x is now equal to, when I add these together, 3,360. When I add the 72, I have a 2, a 3, carry a 1, 4, so I have 3,432. And now I'm going to have to actually do some division. My rule of thumb for myself is that if I am dividing by something that I don't know the first 10 multiples of, then I just use a calculator. So in this case, I'm going to be dividing both sides by 66. So 1 over 66 is what I'm multiplying by on both sides. And although I could work through the process of actually doing this division by hand, this is one of those things that I feel like I grew up in an age with calculators, and I don't think that that's hindered me in life. Okay, I truly think that when you have something divided by 66, it is faster if you just pull out your calculator and do it that way. So because I've gotten through a lot of schooling and that's never been an issue, I've gotten through a lot of real life, it's never been an issue, I see no reason to force you to do something like that by hand. So what I'm going to do is exactly what I would do normally, which is I'm going to pull out a calculator real quick. And I'm just going to go ahead and divide. 3,432 divided by 66. And notice, oh, whoa, 32 on top, a little typo there. Notice we get a nice whole number. We get 52 for x. In a situation like this, we expect a nice whole number because we're talking about a number of tickets sold, and it really wouldn't make a lot of sense to sell a partial number of tickets. Okay, so we got that x is 52, and that means that 52 student tickets were sold. All right, not so bad. Okay, number 19. Daniel has 170 feet of fencing to make a rectangular garden in his backyard. He wants the length to be 35 feet more than the width, so we're going to find the width. Okay, so first things first, whenever the word rectangle or triangle or any shape shows up in a problem, just draw that shape and then try to label it. Okay, nothing's a bigger giveaway that you should be drawing a picture than a shape being described to you. So now, we have 170 feet of fencing to make the garden. So that means the perimeter needs to be 170. So let's just go ahead and label this as length and width. Okay, so length and width here. It says he wants the length to be 35 feet more than the width. So if my width is just plain old W, where notice it says find the width, by the way, that's what tells me to make W the variable I'm looking for, is because width, so W. So W is going to stay W, but I'm going to change L, which is the length, to be 35 more than W. So I'm going to make L over here on the left equal to W plus 35, because that is 35 more than W. So now I can set up an equation for perimeter, where perimeter is equal to the sum of all the sides. So this is W plus W, because that's the top and the bottom sides, and then plus L. But because I know that L is W plus 35, I can just go ahead and substitute that in. So I am going to have W plus, and then right here, instead of just W, or instead of L, I'm going to have W plus 35, and then I'm going to have another W plus 35. Okay, where those two W plus 35s are the two lengths, and our perimeter needs to be 170 feet, because that's how much fencing we have. All right, now this actually ends up being pretty easy to solve. When we combine like terms, this problem becomes real simple real fast. We have 170 on the left is equal to 4W plus 70. It's 35 plus 35. I can go ahead and subtract 70 from both sides. And when I said it would become real easy real fast, we're not even going to need a calculator, because 100 is now equal to 4W. And I think we all know what 100 divided by 4 is. So we're just going to go ahead and multiply by 1/4 on both sides, same as dividing by 4. And this is going to give us that W is equal to 25. And so it says to find the width, and because we have units in our problem, we're going to have to specify that the width is 25 feet. And if you ever want to go back and double check, just plug that in and check. If we had 25 on bottom, 25 on top, that's 50. And then W plus 35, well, 25 plus 35 would be 60. So we'd have 50 for the two widths and then 60 for each length. Add those four numbers together, 60, 60, 25, 25, and you'll get 170. All right, two more applications. Number 20. Taylor has $1.25 in dimes and pennies. The number of pennies is 4 more than the number of dimes. How many of each coin does Taylor have? So in this case, we are not just looking for the number of pennies or the number of dimes. We're trying to find both. So what we're going to go ahead and do is say that D is equal to number of dimes, and that P is equal to the number of pennies. Okay. And you might be thinking to yourself by looking at the problem, well, doesn't it have to be 5 pennies? Because dimes are only multiples of 10 and ends in a 5. But keep in mind, it could be 15 pennies or 25 pennies. Like, it could be more than 5. So try not to fall into the trap of guess and checking how many of each coin. Try to always actually rely on setting up the equations. All right, so we have $1.25 total. Okay, so now just like before in two problems ago, whenever we have a total of something, that is going to tell us to add together the individual parts. Okay, so what we're going to do is add together, just like before, amount 1 plus amount 2, and this is going to equal our total, where our total is the $1.25, so 1.25 here. But then we have to represent amount 1 and amount 2, and so now we have to take into account the fact that we have pennies and dimes. So we're talking about the amount of money in pennies and the amount of money in dimes. To get the amount of money in pennies you have, you would take the number of pennies, which is P in this case, and you would multiply it by the cost of 1 penny, which is 0.01 or 1 cent. Okay, because each penny is worth 1 cent, so if you multiply number of pennies times 0.01, you get the amount of money in pennies. And similarly, 0.1, which is 10 cents, multiplied by D, which is the number of dimes, is going to give you the total amount of money you have in dimes. But this is not good enough, because it says in this middle sentence that the number of pennies is 4 more than the number of dimes. Okay, so this says to me pennies is equal to dimes plus 4. Okay, 4 more than the number of dimes. So where I see a P in my equation down here, I'm going to write D plus 4 in its place, but I'm going to leave everything else the same. Okay, so all I did was replace P, which represented the number of pennies, with D plus 4, because the number of pennies is 4 more than the number of dimes. Okay, so now we can go about solving. In this lesson, we learned how to get rid of decimal places, or how to get rid of decimals in the problem. The most amount of decimals I see is 2. Okay, we have 2 decimal places on the left and 2 on the right. So if I multiply everything here on the left by 100 and everything on the right by 100, I'm no longer going to have to deal with those decimal places. Instead, 100 times 0.01 is just 1. So I'm going to get 1 times D plus 4. 100 times 0.1 is going to give me 10, and that's times D. Now on the right side, 1.25 times 100 is 125. Okay, so now on the left, I have 1 times D plus 4. So I don't even actually need the 1 in the parentheses. This is just D plus 4. And then I have plus 10 times parentheses D. I don't need those parentheses either. So really, I just have D plus 4 plus 10D. So together that is 11D plus 4. I have 125 on the other side. I'm going to go ahead and leave that alone for a second. But now I'm going to subtract 4 from both sides. That is going to give me 11D is equal to 121. And I had been leaving the calculator open thinking I might need it. But hopefully we can all look at 11D equals 121 and decide, you know what, let's throw this calculator away. I know you guys, I left it open on purpose because I wanted to get to a place where you guys could see me actively having it and choosing not to use it. Okay, we should know that 11 times 11 is 121. Okay, that is worth just having committed to memory. So throwing this calculator away, not using it for this division. 11D equal to 121 if I multiply both sides by 1 over 11 or divide by 11. This is going to give me that D is equal to 11. No calculator needed there. All right, and so now we need to find the amount of the other coin we have. We have 11 dimes, but it says the number of pennies is 4 more than the number of dimes. So I have this equation from way up top that P is equal to D plus 4. Okay, all I did was copy it from up here. So if P is equal to D plus 4 and I plug in D equals 11, that is going to tell me that P is equal to 15. And so if we summarize that, that says that we have 11 dimes and 15 pennies. So again, if you fell into the trap of thinking it was 5 pennies at the beginning, it is actually 15. All right, not so bad though. Notice we had an application where we actually needed to get rid of decimal places to make that problem a little bit easier on us. Okay, now we're going to do that same idea, but with fractions. Okay, if you're a fan of Parks and Rec like I am, then you're going to love this problem. You get paid, and suddenly you feel rich, but then life gets real. Let's be honest. Okay, so half of your money goes to rent, a quarter of your money goes to food, a sixth of your money goes towards your car, and now you look at the $100 you have left, and you still feel like a baller. Good for you. How much money did you get paid originally? So now, if you're wondering, Parks and Rec, what? Well, whenever I think the word baller and get all excited about money, my brain instantly goes to Donna celebrating with Aziz Ansari's character, Tom. There you go. And they're celebrating Treat Yourself 20 whatever year they're in. So yeah, I just get excited when we get to celebrate being rich. So you get paid, suddenly you feel rich, life gets real, blah, blah, blah. We have that half of our money goes towards food, a quarter of your money goes towards food. Sorry, first one was rent, quarter goes towards food, a sixth of your money is disappearing for your car, and you have $100 left. So let's think about how did you get to 100? What did you have to do to get down to 100? Well, you started off by getting paid, right? So I'm going to say that X represents the amount you got paid. Okay, so if we start with X, we're going to just take away things from X until we get down to $100. So we spend half our money. Well, how do you represent losing half your money? Minus 1/2 X. Okay, because we didn't just lose half, we lost half of our money. So we have to multiply 1/2 times the amount of money we got. Then we lose a quarter of our money. Okay, so then minus 1/4 X. Then we lose a sixth of our money. Okay, so minus 1/6 X. And so now we have this problem where, oh gosh, like we have a lot of fractions to deal with. So how can we make this a little bit easier on ourselves? Well, one option would be to find a common denominator with all these fractions, change all the fractions to use that common denominator, and then add them together, or in this case, subtract them, go from there. But instead, if we use that same common denominator, which in this case is 12, the least common denominator here, 2, 4, and 6, is going to be 12. If I multiply everything in this problem, both sides by 12, we're going to get to a much easier problem. Where after doing this, I'll go ahead and draw my vertical red line real quick. 12 times x is 12x. Oh, I wanted to be using the black pen. 12x. 12 times 1/2 x is going to be minus 6x. 12 times negative 1/4 x is minus 3x. 12 times negative 1/6 x is minus 2x. And over on the other side, we have 1200. Now look at the left side, 12x minus 6 minus 3 minus 2. Well, that's just x. And what do we have on the other side? 1200. So x, which was your paycheck, is $1,200. Well, isn't that cool that you just multiply by 12, combine like terms, and all of a sudden, boom, x is 1200, just like that. Easy peasy. All right, we have one more application on the title slide. So we got to go all the way back up, then we're done. Your new job at a car dealership offers you $300 plus. So $300 plus 1/5 of your weekly sales over $10,000. Okay, so 1/5 of tells me to do 1/5 multiplied by your weekly sales. So 1/5, and then we're going to multiply this by something that represents your sales over $10,000. And all together, we're hoping that we're going to make $6,000 in this week. Okay, so now we got to figure out, how do we represent 1/5 of your weekly sales amount over $10,000? Well, if you sell $100,000 in cars, that means you sold 90,000 over 10,000, right? And well, how did I get there? I just subtracted 10,000 from the amount I sold. So all we have to do to get to your weekly sales amount over 10,000 is take our weekly sales amount, which we will call X. So over here, I'll say X equals weekly sales. And we just take away $10,000 from it. Okay, that'll give us our amount over 10,000. So now we could go ahead and try to solve this as is, but if we multiply both sides by 5 to get started, it's going to get rid of that fraction for us. That way I don't have to deal with that 1/5 at all. So after multiplying both sides by 5, I'm going to get 5 times 300 is 1,500. That 1/5 goes away, so I just have X minus 10,000. And on the other side, 30,000. All right, so now we can go ahead and combine like terms. We have X, and then 1,500 minus 10,000 is going to leave me with negative 8,500 and 30,000 on the other side. So if we go ahead and take that 8,500, add it over to the other side, we're going to get our answer for X, which is that in order to make $6,000 in 1 week, we are going to have to sell, so have X be equal to $38,500. Okay, so when X is equal to $38,500, we will make $6,000 in that week. So X equals 38,500. And if you're thinking, oh, that's a bad job, how are you ever going to do that? Well, one, making $6,000 in a week sounds like an extremely good week. So that sounds like an awesome job. But also 38,000 in sales, if you're selling cars, that's one car. So I highly doubt that car salesmen are actually making this much money. But if they are, good for them. And hey, maybe a career path to look into. That is not advice, though. I recommend you all become math professors because it is the greatest job on earth.